Okay, today in IM1 we're going to talk about special systems. And these are the exceptions to the rules that we've been solving for up until now. So remember that the solution of a linear system is the point of intersection, right? So that's what we've been solving for up until now, and it's a point, x, y. So now I want to look at this diagram, and I want you to think about this, and I'm going to wait for a sec after each one to see what you're telling me. So notice that we have symbols down here. You always have to pay attention to what you have there. So how many solutions are there for A and B if they were a linear system? So just so you know, there would be no solutions because they are parallel lines. Okay, so parallel lines are never going to cross. Therefore, they have no solutions. Okay, now let's look at a different set. Let's look at B and C. So that's this line and this line. So B and C have one solution. Okay? Okay, now we're going to do another one. And this is going to be, hold on. This is going to be A and D. So here's A. And here's D. Oh, they're parallel too. So they have no solutions because they are parallel too. All right? And the last one we're going to look at is A and D, or not B and D. So here's B and here's D, and they're the same line. So how many solutions do you think? How many points of intersection? Well, every single point on both lines is exactly the same, so there is an infinite number of solutions. Okay? And I misspelled that, so. All right. Okay, so this gives you a little bit better idea. This is showing you B and D together, and you can see that they overlap. And so every single point on them is in common. And they have a term they call coincident. You don't need to know that term, but just know that there is a term that talks about them being coincident or the same line. That's what I go by as the same line. So when you have lines that are the same line, then they have the same equation, and the equations might look different, but they are the same line. And so they share every point. Okay, so this is asking you how many possible solutions, and here are your choices. One solution, zero solutions, or, and this, you can't see the second line, but there's a second line here, which is the coincident or the same line. Okay? So that's what we just talked about. All right, and that was in your journal, so you can find it there. Okay, so solve the system algebraically. So if I was going to solve this, I'm looking for opposites. So I'm going to multiply this equation by -1. And I'm going to get negative y equals negative 3x plus 7. Watch your negatives. Then I'm going to put the other equation underneath. And then I'm going to do like I've been doing. I'm going to add down, but something strange happens. Oh no! I get, whoops, I get 0 equals 11. That's not true. So that means that these are not, this is how I learned as a kid, there is no solution. Okay? So there's no solution here because everything got canceled out and all I'm left with is numbers, and the numbers don't equal each other. Okay? So now what we're going to do is we're going to compare the slopes and the y-intercepts. So we notice that we have the same slope, okay, and we have a different y-intercept. And when that's the case, we know that they are parallel lines, so there is no solution. Okay, so what will you see if there are infinite solutions? You're going to have the same slope and the same y-intercept because it's the same same line, right? And what will you see if there's one solution? A different slope. It doesn't matter what the y-intercept is, it has a different slope. So if you're thinking about an exception, you would say y equals 1/2 x plus 2 and y equals 3x plus 2, and you think, oh, they have the same slope. That just means that that's their point of intersection. Because they have this different slope, they will cross each other. That just means that that's the point. So that's what you have to be careful about, okay? So same slope, different y-intercept, parallel lines, no solution. Same slope, same y-intercept, it means the same line, okay? And infinite solutions. A different slope, boom, one solution. Any lines that have a different slope will eventually cross. Okay, so how would you start to check this one using a slope-intercept comparison? Well, the first thing you want to do is you want to put it into slope-intercept form. So I'm going to add the x over here, always do this first, equals x plus 3. Oh, they have the same slope, different y-intercepts. I'm comparing this one to this one. And if you wanted to graph and check, you could do that too. And there's our two lines. And they are parallel, and they will have no solution. Okay, let's do another one. Okay, so I look at this one. Oh, they have different slopes. Those lines are not parallel. They have, since they have a different slope, we know immediately that they have one solution. Okay? And there's the solution. All right, so let's look at some different equations and see what we can see. So when it tells you to compare slopes and y-intercepts, the first thing you have to do is put them all in slope-intercept. So this one's in slope-intercept, all the top ones are in slope-intercept, but the bottom ones aren't. So you have to redo them and then compare. So I've redone the first one, and I can see, oh, same slope, different y-intercept. These are parallel lines with no solution. Okay, I'm going to put the next set in slope-intercept. Again, same slope. Oh, same y-intercept. Think about what that means. It's the same line, infinite solutions. Let's look at the last one. Different slope. Same y-intercept. Doesn't matter. Okay, different slope, one solution, and the solution is the y-intercept because that's where they intersect. And so that doesn't matter. So if you want to look at this over slowly, pause and think about it. But remember, you want to know the difference. Okay, when you're looking and solving algebraically, it's not going to tell you this is a special system, solve it. So you have to be thinking every time you do it. So if you didn't notice that the slopes were equal on this one, what you might do is set them equal to each other. So what does it look like when you do that and you find out that you don't have a different, that is a special system? So what's it look like? How to recognize? So first thing I'm going to do is I'm going to solve, just subtract -2/3 x over to the other side. And I go, wait a minute, there's going to be nothing left there. Do not write 0x. That's nothing. Okay, so 0 equals -5. And then I go, oh, that's not true. So there's your no solution. Okay, so that's what it looks like. Let's see about this one. This one we solved by substitution. Let's do elimination. So first thing I'm going to do is I'm going to multiply this one to get an opposite here. So I'm going to multiply by -3. So I'm going to write the first equation again, 15x minus 6y equals 9. And then I'm going to multiply this one by -3. So I get -15x plus 6y equals -81. And then I'm going to add, but oh no, all my x's are gone, all my y's are gone, and I get 0 equals -72, which is not true, so this is no solution. So if all the variables disappear and you're left with just numbers, if they are not equal, then there are no solutions. Okay, so we saw what happens with a no solution. We end up with numbers that don't equal each other. So what happens with an infinite solution if I solve it algebraically? If I don't do slope-intercept form and figure that out first? So what I'm going to do is I have to make an opposite here. So I'm going to multiply this. I'm going to do it with eliminations. I'm going to multiply this one by 3. So I get negative 9x plus 15y equals 45. Then I rewrite the other equation underneath. And then I'm going to add. Okay, remember we add vertically. So, those cancel, and those cancel. So I get 0 equals 0, which is a true statement. So that's what happens if you solve it algebraically. All the numbers disappear. The constants disappear, the y's disappear, and the x's disappear, and you get 0 equals 0. So if you get that answer, then you'll know that it's infinite solutions, that they are the same line. Okay, so this is just telling you about the 3 different methods that we learn to solve systems by graphing, substitution, and elimination. But I added this one because sometimes if we already have them in slope-intercept form, like up here, we can compare them really quick and say, okay, they have a solution. I'm going to go ahead and solve. But, so it's always important that if it's in slope-intercept form, you can quickly check that. So remember, look at what you were doing. For graphing, you would want it in slope-intercept form. But to verify, you're going to want to do substitution or elimination. And substitution, you need to solve for a variable. So you have a substitute. For elimination, I like when they're in standard form. I always pick elimination if they're in standard form. So you get to figure out which method you like the best and how you like to use it and in what form. Okay, so we're going to do a word problem and we get to choose. So we're going to talk, since we're talking about special systems, we'll probably work with that. So Jared and David both started a savings account in January. So if we were going to put these in slope-intercept form, this would be the y-intercept because this is where they started. So we're going to go Jared, okay, and we've got y equals, and what is Jared adding? So Jared's adding $5. So y equals 5x plus he started with 25. And then we're going to look at David. David started with $40, so we're going to put the y-intercept down. And now we have to figure out how much he's adding. Oh, he's adding $5 too. So 5x. So now it says, if the pattern of savings in the table continues, when will the amount in Jared's account equal the amount in David's account? So the first thing you're going to notice is they have the same y-intercept. The same slope. They have different y-intercepts. That means that these are parallel lines. Jared starts at 25, David starts at 40, and they are never going to meet because David isn't saving, or Jared isn't saving enough to catch up. Now, if Jared had 8x, then his graph would look like this, and eventually he would catch up, but it's not. And so he is never going to catch up to David because they are parallel lines. Okay? So you could also solve it and you would find that it's no solution as well. Okay? So you go 5x plus 25 equals 5x plus 40. Cancel both sides. 25 does not equal 40 and therefore not going to happen. He's not going to catch up. Okay, so let's look at 2 more guys. Okay, we have Matt and Ben. So Matt's equation, he starts with $100 and he's depositing $30 per month. Okay, Ben starts with $80 and he has $20 per month. Now, you might say, oh yeah, they're going to intersect, but are they ever going to catch each other? So here's what you need to know. So we're starting one at 80, 10, 20, 30, 40, 50, 60, 70, 80, and one at 100. But this guy is going up slower than this guy. He has a larger slope. This is Matt, this is Ben. So if I set them equal to each other, going to subtract 20x from both sides, keep my x's positive. I get 10x equals, then I'm going to subtract 100, and I get negative 20, divide by 10, and I get x equals negative 2. Well, we're talking about months. Do we have negative months? Did he have money before then? We don't know. We start at month 0 when he had 100 and Ben had 80. So the answer to this one is no, Ben can't catch up to Matt because he's not saving enough per month. Okay? So that's really important that you think about the logic of the problem as well. Okay, so here's an exit ticket for you. So what you're going to be doing first is number 1, you're going to be solving this. You're going to be putting them in slope-intercept form and comparing them. And you're going to tell me what you found. Okay, that will be the answer. And in this number 3, you have a word problem. So you're going to write the system. You're welcome to write the system like this, next to each other, and then you're going to answer the question. Okay, make sure you explain in terms of the problem situation. Do not tell me that the slopes are the same, the y-intercepts are the same, the slopes are different, whatever. You're going to explain in terms of the problem. So have fun with that exit ticket, and we're done for today.